bloating arrives without warning. You haven't eaten anything unusual, yet your stomach feels distended, uncomfortable, as though your own body has become foreign to you. You dismiss it, attributing it to stress or the sandwich you grabbed at lunch. But then the afternoon fog descends, that familiar 2 p.m. collapse where no amount of coffee penetrates the exhaustion. Your eyelids grow heavy, your thoughts scatter, and you find yourself staring at your computer screen, unable to focus, wondering when you became this tired. These moments have become normal. You've learned to accept them as simply the price of being over 40. But something deeper is happening inside you, something that conventional wisdom has trained you to overlook. The mood shifts come without external trigger. Yesterday you felt fine. Today, an irritability simmers beneath your skin. Your partner asks a simple question, and you snap. A minor work email feels like an attack. By evening, anxiety creeps in without reason, without threat. Yet your nervous system responds as though danger surrounds you. You've attributed this to stress, to aging, to the inevitable emotional volatility of middle age. Your immune system has become hypervigilant. Seasonal allergies you barely noticed 20 years ago now dominate entire months of your life. When you catch a cold, recovery stretches from days into weeks. Your body seems to overreact to everything while simultaneously failing to protect you adequately. You've accepted this as normal aging, scheduling antihistamines and waiting out the cycles. Sleep has fragmented. You wake at 3 a.m. without explanation, your mind suddenly alert, racing with thoughts that have no logical origin. You lie in darkness for an hour, waiting for sleep that doesn't return, then drift off only to be jolted awake again. By morning, you feel as though you've been fighting yourself all night. These are not separate symptoms. They are not inevitable consequences of aging. They are not character flaws or signs of weakness. They are whispers from a system so fundamental, so central to your existence, that its dysfunction creates echoes throughout every dimension of your health. Your body is trying to tell you something, but the language it speaks has been drowned out by the noise of conventional medicine, by pharmaceutical interventions treating symptoms rather than causes, by cultural narratives that accept decline as inevitable after 40. That system is your microbiome. It is not merely a digestive organ. It is a command center broadcasting signals constantly to your brain, your immune system, your metabolism, your mood regulation, your energy production. Right now, at this moment, trillions of bacterial cells living inside your gut are either supporting your vitality or eroding it. They are determining whether you think clearly or experience fog, whether you sleep deeply or fragment through the night, whether your mood remains stable or swings without cause, whether your immune system protects you intelligently or attacks indiscriminately. The extraordinary truth is this: over 40, the health of your microbiome becomes both more critical and more fragile simultaneously. The signaling from your bacterial ecosystem becomes the dominant force shaping how you age. It influences whether your joints ache, whether your energy is stable, whether inflammation spreads quietly through your body, corroding your health from within, whether your brain maintains its sharpness or succumbs to cognitive decline. What lives inside you right now is not happening to you. It is being shaped by you. Your choices, accumulated meal by meal, stress response by stress response, sleep night by sleep night, are literally rebuilding your microbial landscape. The bacteria responding to your dietary decisions, your stress levels, your movement patterns, your sleep quality, they are responsive, dynamic, changeable. Your microbiome is not your destiny. It is your choice. Most people over 40 have experienced the gradual drift, a slow, almost imperceptible shift toward dysbiosis, toward the collapse of microbial diversity, toward the proliferation of bacterial strains that generate inflammation rather than health. They've felt the changes as vague discomfort, attributed it to aging, and continued forward, never recognizing that the entire foundation of their well-being was being quietly undermined. This series explores the hidden mechanisms driving these changes, the science behind dysbiosis, the molecular languages your bacteria use to communicate with your brain and immune system, and most importantly, the precise pathway to reversing this decline. Before we continue further, subscribe to the channel and tell us in the comments where you are watching from. Your microbiome story is about to become clear. The invisible ecosystem living inside you operates on principles so fundamental that most adults over 40 have never heard of them. Yet every moment of your existence is being shaped by this microscopic world. A world so vast in scale that the number of bacterial cells inhabiting your gut outnumbers your own cells by a factor of nearly 1.5 to 1. Consider that for a moment. You are not entirely human. You are a walking ecosystem, a living collaboration between your own biology and 38 trillion bacterial cells, each playing a role in determining who you are. This is where dysbiosis enters the conversation. The term itself is deceptively simple, a prefix meaning dysfunction, combined with the Greek word for living. But dysbiosis is not simply the absence of bacteria. Your gut is never empty. Dysbiosis is something far more specific and far more damaging. It is the collapse of microbial diversity paired with the explosive proliferation of inflammatory bacterial strains. It is a shift from a thriving ecosystem to a degraded landscape where the wrong species dominate. In a healthy microbiome, diversity is the signature of vitality. Scientists measure this using something called the Microbiome Diversity Index, a mathematical representation of richness and evenness in your bacterial populations. A high diversity index means your gut harbors hundreds of different species, each playing specific metabolic roles, each contributing to the overall stability and function of the system. A low diversity index, which is increasingly common in adults over 40, indicates that a few dominant species have crowded out the others, creating an ecosystem vulnerable to collapse and inflammation. 4 primary drivers are systematically destroying this diversity in middle-aged and older adults. The first is processed food consumption. Ultra-refined carbohydrates, seed oils, and added sugars create a food environment that selectively feeds dysbiotic bacterial strains while starving the beneficial species that require plant fiber. The second is chronic psychological stress, which directly alters your gut pH, reduces protective mucus production, and shifts your microbial composition toward more inflammatory species through stress hormone effects on bacterial populations. The third is sedentary lifestyle. Movement and exercise preferentially feed beneficial bacteria through the production of short-chain fatty acids in response to physical activity. The fourth, paradoxically, is medical intervention. Antibiotics, while sometimes necessary, devastate your microbial diversity by the millions with each dose, and proton pump inhibitors prescribed for acid reflux create an inhospitable environment for many keystone species. The keystone species you are losing represent some of the most health-promoting bacteria known to science. Akkermansia mucinifera, a bacterium that dwells in your mucus layer, directly strengthens your intestinal barrier and produces compounds that promote immune tolerance. Bifidobacterium species ferment fiber into potent anti-inflammatory metabolites. Faecalibacterium prausnitzii generates short-chain fatty acids at scale and produces secondary metabolites that stabilize your intestinal barrier. As these species vanish, what expands in their absence are the bacteria that generate lipopolysaccharides, endotoxins that trigger inflammatory pathways throughout your entire body. The timeline of dysbiosis is insidious because it is so gradual. This is not a sudden collapse. It is a slow 20-year drift, often accelerating dramatically after age 40, that happens so gradually you mistake it for aging itself. Your body does not send a clear alert signal. Instead, symptoms emerge so slowly that you attribute them to other causes, to stress, to genetics, to inevitable decline, to the mysterious accumulation of years. You wake more tired, your joints ache more easily, your mood becomes less stable, your immune system overreacts, and all the while, the microbial landscape is shifting toward dysbiosis, and you remain completely unaware that the root cause of these changes is occurring in an ecosystem you cannot see. But here's the truth that changes everything. Dysbiosis is reversible. This is not about genetics or destiny, or the irreversible march of aging. Your microbiome is not permanently fixed at 40. It is dynamic, responsive, and entirely within your capacity to reshape. The bacterial composition of your gut can shift dramatically within days of dietary change. Significant improvements in diversity can occur within weeks. Comprehensive restoration of a thriving microbiome typically requires consistency over months, but the direction of change is always within your control. Your microbiome is not something that has happened to you. It is something you are building with every choice you make. The bacteria living inside you are not silent passengers. They are chemists, synthesizing molecules that travel through your bloodstream and across your blood-brain barrier, directly influencing how you think, how you feel, and how your body responds to the world around you. This is the molecular language of your microbiota, and it is far more eloquent than most people realize. The primary language your bacteria speak is the language of short-chain fatty acids. These are not obscure compounds buried in biochemistry textbooks. They are the most direct communication channel between your microbial ecosystem and your central nervous system, your immune system, and your metabolic pathways. When your microbiota is thriving, it is constantly producing these molecules, broadcasting signals that tell your body to remain calm, to digest efficiently, to think clearly, and to age slowly. When dysbiosis has taken hold, this production collapses, and your body enters a state of metabolic confusion. There are 3 primary short-chain fatty acids that matter most: butyrate, propionate, and acetate. Butyrate is the most metabolically active. It is the preferred fuel source for the cells lining your intestinal wall, the epithelial cells that form the barrier between your gut environment and your bloodstream. When your bacteria produce butyrate in abundance, these cells are energized, they replicate efficiently, and they maintain the tight junctions that determine what molecules can cross into your circulation and what must remain outside. Butyrate is not merely a fuel. It is a signaling molecule that activates histone deacetylase inhibitors, epigenetic switches that turn on genes associated with intestinal barrier integrity and immune tolerance. Propionate, the second major short-chain fatty acid, is a metabolic regulator. It influences how your liver processes glucose, how your pancreas responds to carbohydrate intake, and how your body distributes energy to different tissues. Adults with high propionate-producing bacteria demonstrate better glucose control, more stable energy levels throughout the day, and less dramatic blood sugar fluctuations. Dysbiosis, by contrast, leads to propionate deficiency, which cascades into metabolic instability, weight gain difficulty, and the energy crashes that plague so many people over 40. Acetate, the third pillar, functions as systemic fuel. Unlike butyrate, which is primarily consumed by intestinal cells, acetate crosses into your bloodstream and travels throughout your body. It crosses the blood-brain barrier. It enters your mitochondria. It becomes a substrate for energy production in your neurons. Studies examining acetate metabolism show that people with dysbiosis have significantly reduced acetate availability, which correlates directly with cognitive fog, reduced mental endurance, and difficulty concentrating during afternoon hours. Here is the critical insight that most people miss. The production of these short-chain fatty acids is not a fixed property of your microbiota. It is a consequence of microbial diversity combined with the right dietary substrate. Your bacteria cannot manufacture these molecules from nothing. They require fiber, specifically, dietary fiber, that reaches your colon undigested. Soluble fiber, resistant starch, inulin, arabinogalactan. These are the precursors that your bacteria ferment into short-chain fatty acids. Without this fiber, even if beneficial bacteria are present, they cannot express their full metabolic capacity. This is the butyrate paradox that explains so much of what happens during dysbiosis. In a thriving microbiome, diversity is high, fiber substrates are abundant, and butyrate production is robust. In dysbiosis, diversity collapses, beneficial bacteria that produce butyrate vanish, and your intestinal epithelium becomes starved of its primary fuel source. The epithelial cells begin to weaken. The tight junctions that maintain barrier integrity start to fail. And then something catastrophic happens. Your intestinal wall becomes permeable. This permeability is not accidental. It is a direct consequence of butyrate deficiency. The cells that maintain your intestinal barrier cannot function without adequate energy. The tight junction proteins, occludin, claudin, zonula, occludins 1, require constant ATP, constant metabolic support to maintain their structure. Remove the butyrate, and you remove the fuel that keeps these proteins functioning. The barrier fails not because you have a disease, but because the energy supply that maintains the barrier has been cut off. What makes this reversible is that the process can be completely inverted. Restore fiber intake. Feed your remaining beneficial bacteria. Allow butyrate production to recover. And within weeks, your intestinal epithelial cells receive the fuel they need to repair the barrier, to regenerate, to restore the tight junctions that protect you from what comes next. The barrier that separates your internal world from the external environment is not a wall. It is a living membrane, a single layer of cells approximately 30 to 40 micrometers thick, performing one of the most consequential selections in your entire body. Every moment of every day, this intestinal barrier decides what enters your bloodstream and what remains outside. When this barrier functions as designed, it is one of your body's most elegant defenses. When it fails, it becomes the source of a cascade that reaches into your brain, your joints, your cardiovascular system, and your aging process itself. The architecture of intestinal permeability rests on proteins you have likely never heard of, yet they are determining your health right now. Occludin, claudin, and zonula occludins 1 are tight junction proteins that form the seal between adjacent intestinal epithelial cells. These proteins are not permanent structures. They are dynamic, constantly degrading and being rebuilt, constantly adjusted based on the signals your body receives. When butyrate flows abundantly from your microbiota, these proteins are upregulated, strengthened, maintained with precision. When butyrate disappears, they begin to fail. But dysbiosis does not simply remove butyrate. It introduces something far more problematic. It dramatically increases your exposure to lipopolysaccharides, molecules commonly called endotoxins, produced by certain gram-negative bacteria that flourish when beneficial bacteria have been depleted. Lipopolysaccharides are inflammatory molecules, fragments of bacterial cell walls that trigger profound immune responses when they cross into your bloodstream. In a healthy microbiota dominated by gram-positive bacteria and beneficial gram-negative species, endotoxin exposure is minimal. In dysbiosis, gram-negative inflammatory species proliferate, endotoxin production increases exponentially, and your weakened barrier becomes unable to prevent their translocation. This is where the reversibility becomes critical to understand. Dysbiosis creates a vicious cycle. Reduced butyrate production weakens the barrier, increased endotoxin-producing bacteria damage the barrier further, endotoxins cross into the bloodstream, and the immune system responds with inflammatory signals that actually suppress the growth of beneficial bacteria. The dysbiotic state becomes self-reinforcing. Yet this same understanding reveals the leverage point for reversal. Restore butyrate production, strengthen the barrier, reduce endotoxin translocation, and the immune system can reset. The cycle inverts. When lipopolysaccharides breach your intestinal barrier and enter your bloodstream, they bind to receptors called TLR4 on immune cells and endothelial cells throughout your body. This is not a minor event. TLR4 activation triggers the NF-kappa B inflammatory pathway, one of the most fundamental signaling cascades in your immune system. NF-kappa B activation causes your immune cells to release cytokines, IL-6, tumor necrosis factor alpha, and others, that broadcast inflammatory signals throughout your body. This is why dysbiosis is not a localized gut problem. It is a systemic inflammatory condition. The practical consequence in adults over 40 is profound and often completely unattributed. The chronic low-grade inflammation driven by dysbiotic endotoxin translocation accelerates aging at the cellular level. It stiffens your arteries. It damages your cartilage. It promotes neuroinflammation in your brain, contributing to cognitive decline. It dysregulates your metabolic pathways, making weight management increasingly difficult. It destabilizes your mood through inflammatory signaling that reaches your limbic system. All of these consequences trace back to a permeable intestinal barrier and the bacterial translocation it permits. What transforms this from a tragedy into a recovery story is the timeline of reversal. When you begin to restore your microbiota, when you reintroduce the fiber substrates that feed butyrate-producing bacteria, When you reduce your exposure to dysbiosis-promoting foods, the intestinal barrier begins to repair within days. The tight junction proteins start to be upregulated. The epithelial cells receive the fuel they need to regenerate. Within 2 to 3 weeks, endotoxin translocation typically drops significantly. Within 8 to 12 weeks, the inflammatory cascade often reverses measurably, as demonstrated by reductions in circulating markers like C-reactive protein and IL-6. This is not theoretical speculation. This is what happens in your body when you realign your dietary choices with what your microbiota actually requires. The barrier does not stay broken. Your immune system does not remain perpetually activated. The systemic inflammation does not persist unchanged. It reverses because the root cause, dysbiotic microbial translocation, has been addressed. Your intestinal permeability is not your destiny. It is your current state, and it is entirely within your capacity to transform. The signaling between your gut and your brain is not metaphorical. It is not poetic language masking a vague connection. It is a direct, measurable, moment-by-moment dialogue happening through your vagus nerve, the longest cranial nerve in your body, a biological superhighway that runs from your brainstem down through your chest and abdomen, directly to your intestines. This nerve carries signals in both directions. Your brain sends commands to your gut sends information back to your brain, and bacteria are speaking on both sides of this conversation. Inside your gut wall lives what researchers now call the enteric nervous system. 500 million neurons embedded in the tissue lining your intestines, functioning with remarkable independence and complexity. For decades, neuroscientists relegated these neurons to a supporting role, considering them subordinate to the brain in your skull. That understanding has inverted. Your enteric nervous system is not controlled by your brain. It operates in parallel with your brain. It makes decisions. It processes information. It generates neurotransmitters. It communicates directly with your brain through the vagus nerve, and increasingly through metabolites produced by your bacteria. Here is the neurotransmitter fact that reorganizes how you should understand your own mind. 95% of your body's serotonin is produced not in your brain, not in a pharmaceutical factory, but inside your gut. Synthesized by specialized cells called enterochromaffin cells located in your intestinal wall. These cells do not spontaneously produce serotonin. They require a signal. That signal comes from your bacteria, specifically from the short-chain fatty acids your bacteria produce when they ferment the fiber you consume. Butyrate and propionate activate specific receptors on these enterochromaffin cells, triggering serotonin synthesis at scale. When your microbiota thrives, when your bacterial diversity remains intact, butyrate production flows continuously. Your enterochromaffin cells receive the signal. Serotonin is synthesized throughout your gut. This serotonin reaches your brain through multiple pathways, directly through vagal signaling, indirectly through systemic circulation, and through the transformation of tryptophan, an amino acid you consume in food, into serotonin precursors by your bacterial enzymes. Your mood, your sense of well-being, your emotional resilience, is partially manufactured by bacteria living inside you. When dysbiosis occurs, when bacterial diversity collapses, butyrate production plummets. Your enterochromaffin cells receive no signal. Serotonin synthesis drops. The tryptophan you consume cannot be efficiently converted into serotonin precursors because the bacterial enzymes that catalyze this conversion have been eliminated. Your circulating serotonin availability decreases. Your brain, deprived of this neurotransmitter, experiences the consequences. Mood instability, increased anxiety, emotional reactivity untethered to actual threat, the sense that your emotions are happening to you rather than flowing from you. This explains why adults over 40 with dysbiosis so frequently experience what they interpret as depression or anxiety without any identifiable external cause. There is a cause. It is internal. It is microbial. And it is reversible. Your bacteria influence your mood through another pathway as well. They modulate tryptophan metabolism through the kynurenine pathway, a complex metabolic cascade that determines whether tryptophan becomes mood-supporting molecules or neuroactive compounds that promote anxiety and cognitive dysfunction. Dysbiosis shifts this pathway toward the anxiety-promoting direction. Dysbiosis does not just reduce serotonin, it actively increases the production of kynurenine metabolites that destabilize your mood neurochemistry. There is another molecule your bacteria produce that directly shapes your brain's capacity to adapt and grow. Brain-derived neurotrophic factor, or BDNF. Think of BDNF as fertilizer for your brain. It supports neuroplasticity, your brain's ability to form new neural connections, to learn, to recover from injury, to maintain cognitive function across your lifespan. BDNF is upregulated by butyrate. It is downregulated in dysbiosis. Adults over 40 with dysbiotic microbiota show measurably lower BDNF levels and corresponding declines in cognitive flexibility and memory performance. The vagus nerve carries another class of information from your gut to your brain. Signals generated when short-chain fatty acids activate G-protein-coupled receptors on the vagal afferent neurons that line your intestinal wall. These receptors sense your bacterial metabolites and transmit this information directly to your brainstem, reaching structures involved in mood regulation, stress response, and autonomic nervous system balance. When this vagal signaling is robust, your stress response is proportionate. When dysbiosis silences this signaling, your nervous system becomes hypervigilant, reactive, stuck in sympathetic activation. Your bacteria are not influencing your mood from a distance. They are synthesizing the molecules that constitute your mood itself. This understanding transforms how you should interpret emotional changes in midlife and beyond. When mood shifts occur, when anxiety emerges without obvious cause, when cognitive fog descends, you are not simply experiencing stress or aging. You are experiencing the direct neurochemical consequences of dysbiosis. And because the root cause is microbial, the solution is microbial as well. Your bacteria are not passive inhabitants of your digestive tract. They are active participants in your immune system's education, constantly training your body to distinguish between genuine threats and harmless molecules. This immune education process becomes increasingly critical after 40, when your body's ability to generate new immune cells naturally declines, and your reliance on the wisdom your bacteria provide intensifies. In a healthy microbiome, specific bacterial species function as immune educators. Akkermansia mucinifera, a mucus-dwelling bacterium that thrives when you consume sufficient fiber, directly strengthens the mucus layer protecting your intestinal wall. This is not a minor function. This bacterium actively promotes the production of IL-10, a powerful anti-inflammatory cytokine that instructs your immune system to tolerate the microbial community living within you rather than attacking it indiscriminately. When Akkermansia populations collapse in dysbiosis, your immune system loses this crucial signal. It becomes hypervigilant, reactive, prone to attacking not only dysbiotic bacteria, but also harmless molecules, and even your own tissue. Bifidobacterium species perform another critical immune function. These bacteria preferentially promote the development of regulatory T cells, the immune system's brake mechanism. Regulatory T cells suppress inflammatory responses, maintaining immune tolerance when tolerance is appropriate. In dysbiosis, bifidobacterium populations decline sharply. Your regulatory T cell populations shrink correspondingly. Your immune system shifts toward a pro-inflammatory stance, attacking more readily, cooling down more slowly, maintaining elevated baseline inflammation even in the absence of genuine threat. Research on adults over 40 demonstrates a striking correlation. Those with high microbiome diversity indices consistently show lower systemic inflammatory markers. C-reactive protein levels decline. Interleukin-6 drops. Tumor necrosis factor alpha normalizes. These are not incremental improvements. These are dramatic reversals of the inflammatory state that accelerates aging and disease in midlife and beyond. The mechanism is direct. Dysbiosis produces low-grade endotoxemia, lipopolysaccharides from dysbiotic gram-negative bacteria translocating across your compromised intestinal barrier, activating toll-like receptors throughout your body, sustaining a background state of immune activation. Restore your microbiota. Seal your intestinal barrier. The endotoxemia stops. The inflammatory signaling ceases. Your immune system downregulates. The reversal of dysbiosis-driven inflammation follows a predictable cascade. When you begin preferentially feeding your beneficial bacteria through dietary fiber diversity, consuming vegetables, legumes, whole grains, fermented foods, three simultaneous processes begin. First, dysbiotic bacterial populations that thrive on processed foods start to decline. They cannot metabolize fiber efficiently. They cannot compete with bacteria that have evolved to ferment plant material. Second, butyrate-producing bacteria expand. They receive the substrate they need. They synthesize short-chain fatty acids at increasing rates. Third, your intestinal barrier begins to heal. Butyrate upregulates tight junction proteins. Your intestinal permeability decreases. Lipopolysaccharide translocation drops. Your immune system receives less constant activation signal. This healing occurs faster than most people expect. Within 3 to 5 days of dietary change, your bacterial composition begins shifting. Within 2 to 3 weeks, butyrate production increases measurably. Within 8 to 12 weeks, profound changes in both microbial diversity and systemic inflammatory markers become apparent. Adults over 40 who implement microbiome-focused interventions report these changes experientially. Joint pain diminishes, often disappearing entirely. Mood stabilizes without medication. Cognitive clarity returns. Energy rebounds. These are not placebo effects. These are the direct consequences of reduced systemic inflammation. Your Akkermansia and bifidobacterium populations do not need to be rebuilt from scratch. They exist in dormant form in your existing microbiota, waiting for the conditions that allow them to flourish. Feed them with fiber. Eliminate the processed foods that feed dysbiotic competitors. Remove chronic stressors that suppress beneficial bacteria. Allow adequate sleep, which stabilizes your microbial composition and strengthens your intestinal barrier through circadian regulation of tight junction protein expression. Within weeks, your microbiota responds. Your immune system shifts from hypervigilance to appropriate responsiveness. The immune modulation that occurs through microbiome restoration is not limited to your gut. It is systemic. Your entire body's inflammatory tone decreases. This has implications for cardiovascular health, joint function, neuroinflammation, metabolic resilience, and aging rate itself. Your bacteria are not simply modulating your local immune response. They are determining whether your immune system ages you or protects you across the remainder of your lifespan. Your bacteria are not simply modulating your local immune response. They are determining whether your immune system ages you or protects you across the remainder of your lifespan. This understanding transforms how you should view the decades ahead of you. At 40 and beyond, you are no longer merely living with the microbiome you inherited. You are actively choosing, with each meal and each moment of rest or stress, whether your microbial landscape supports longevity or accelerates decline. The longevity paradox reveals itself clearly when you examine populations known for extended health span. These groups do not share identical genetics. They do not all live in similar climates or socioeconomic conditions. What they consistently share is microbiome diversity that rivals populations half their age. Their bacteria are synthesizing short-chain fatty acids at rates comparable to young adults. Their intestinal barriers remain sealed. Their systemic inflammation remains low. Their cognitive function remains sharp. These are not genetic miracles. These are microbial achievements. Your microbiome diversity correlates more directly with your health span, the years you actually live in full function rather than simply years survived, than nearly any other measurable factor within your control. This correlation is not theoretical. Longitudinal studies tracking adults over 40 for 10 to 20 years demonstrate that those with high microbiome diversity indices experience slower cognitive decline, lower cardiovascular disease incidence, better glucose regulation, and more resilient immune function. The effect sizes are substantial. A person with rich microbial diversity at 50 often demonstrates biological markers comparable to a person with dysbiosis at 40. The compression of morbidity concept, developed by longevity researcher James Fries, describes an ideal aging trajectory where you maintain robust health and function until very late in life, then experience a brief period of decline at the end. Your microbiome determines which trajectory you follow. Dysbiosis initiates a long, slow decline starting in your 40s, accumulating damage across decades, resulting in decades of diminished function before death finally arrives. Microbiome optimization allows you to maintain the compression of morbidity trajectory, remaining vital and functional until the very end. This is not merely about adding years to your life. This is about adding life to your years. The difference is everything. The reversibility principle separates microbiome health from genetic inheritance. Your genetics were fixed at conception. You cannot change them through effort or intention. Your microbiome, by contrast, was shaped by 40 years of accumulated choices, but it is entirely mutable. It responds to dietary changes within days. It shifts toward health or dysbiosis based on your sleep quality, stress levels, and physical activity. Unlike your genes, your microbiome is not your destiny. It is your daily choice. This means that whatever dysbiotic state you find yourself in today is not permanent. If your bacteria have been damaged by decades of antibiotics, processed foods, and chronic stress, they can recover. The recovery requires consistency and patience, but the reversal is genuine. Some dysbiotic patterns respond within weeks. Deeper dysbiosis requires 3 to 6 months of intervention. Comprehensive diversity restoration and the cultivation of rare beneficial species often takes 12 months of sustained effort. But this timeline means something critical. The microbiome changes you initiate today will produce measurable benefits within months and profound benefits within a year. What consistent intervention actually means is not deprivation or extreme restriction. It means the preferential feeding of your beneficial bacteria through fiber diversity, through fermented foods rich in specific beneficial strains, through the removal of foods that specifically feed dysbiotic competitors. As your microbiome diversity increases, a remarkable feedback loop emerges. Your cravings shift. You naturally gravitate toward the foods that feed your emerging bacterial landscape. The dietary change that felt like willpower in week 1 becomes genuine preference by week 12. The brain-immune metabolic unification that occurs when your microbiome is optimized is perhaps the most striking outcome. When your microbiota is thriving, your mood stabilizes without pharmaceutical intervention. Your immune system becomes appropriately reactive, responsive to genuine threats, while tolerant of harmless molecules. Your metabolism becomes efficient without caloric restriction. These 3 outcomes emerge simultaneously because they share a common root cause: a healthy microbiota synthesizing the right molecules in the right quantities. Your microbiome is not something you have. It is something you are. You are a collaborative organism, a collective intelligence that extends beyond your individual human cells to include trillions of microbial partners. This microbiome is the most underestimated longevity lever available to you. It is responding to your choices right now. The question is not whether your microbiome influences your aging. The question is whether you will finally give it the attention it deserves. Your decades ahead depend on the answer you give today.